Engineering practices for achieving stability.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
Thanks for visiting me again here on Programming with Palermo. I'm Jeffrey Palermo, your host, and today we are going to talk about stability, achieving stability, and we're going to do a rundown of the engineering practices that we suggest that you use to achieve stability. Not an exhaustive list, but these are the practices that every .NET team should be using in order to achieve stability in a production environment. Remember, the clear measure way has several pillars. The first one is establishing quality. That's first, establishing quality. The second is achieving stability in production as the software is running in a production environment. And then finally, we can turn to our team and increase the speed that our team is moving at, increase productivity, and help them go faster. But first, after establishing initial quality in the software, we need to achieve stability. That's what we're going to talk about today. And so let's get into it. All right, let's get into the engineering practices that help with achieving stability. After we establish quality, we're going to achieve stability with the software running in production. And that's the second pillar of the clear measure way along the path to increasing speed. And a reminder, and I'm just going to show my show notes right here on the screen. As a reminder, your team is going to be wasting capacity, chasing and diagnosing production issues, and then working to fix them if you don't achieve stability in production. So that's super important that you do that. And so let's talk about the suggested engineering practices that help you with achieving stability. And I want to remind you, there's two goals here. There's two goals. We want to prevent the production issues in the first place, reduce the number of them. We want to prevent them. And then when they occur, we want to be very, very quick to correct them. And so some of these, the first half are preventative in nature and are going to reduce the amount of issues you have to begin with. And then the second half are going to aid in quickly correcting those. And so let's just go through them. Automated deployments is the first thing. And there's some that kind of go hand in hand. Automated deployments, formal release candidates. But automated deployments, if you are still deploying any portion of your software manually, then that just leaves a closable hole open for issues.
Programming with Palermo is brought to you by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, ClearMeasure can help while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
And I want to show anyone who's followed me for any length of time has probably seen a version of this poster. And this is a automated DevOps poster. And I'm just going to kind of zoom out to the whole poster. If you just send me an email, we've given away so many copies of this poster. It's high resolution, 2 foot by 3 foot DevOps architecture poster. And I want to focus on the top portion, just talking about the automated flow. Okay. And there is a process to automated deployments. You need at least 3 environments because there's 3 distinct types of environments, and you need at least one. And of course, production environment, you need at least one of those, but plenty of software has multiple production environments. If they have a multi-tenant configuration or have a production environment per customer or per region, there's so many reasons why you might have multiple production environments. And backing off from production, there needs to be some environment that you can do manual testing in. The common names for it are UAT, test, staging, all kinds of names for an environment that a person can do some manual testing in. That's the second type of environment. The third type of environment, first in line, is the automated test environment. I like to call this the TDD environment. Invokes test-driven development, but that's where we run our full system acceptance tests, our load tests, our capacity tests, stress tests, penetration tests, because all of these environments should be production-like in nature. So yes, there's some things that you don't actually know 100% proof until you go to production, but there's a ton of things, there's a ton of issues that you can ferret out in the automated environment, the TDD environment. And so you need at least one of each of these distinct types of environments, and they go in sequence. And so immediately after our integration build runs, we package up our release candidates, and then our automation automatically deploys to our TDD environment and runs those test suites that we have set up to be automatically run. And knowing that, we don't even deploy to a manual test environment until we know those tests have run, because we don't want to waste anybody's time if there's an issue that got through to that stage. So you need to have automated deployments because that allows you to iterate really, really fast. That allows you to have an idea for a change in the morning and have that moving down your pipeline in a matter of hours. You make a change, you push the change into your Git source control, and then your automation takes over. Okay, so that's automated deployments. Now, what sometimes goes hand in hand with that is formal release candidates. And when I say formal, I mean numbered. Okay, numbered and named. You want to have release candidates where you can say version 2.1.503 of this software application is now in the TDD environment, is now in the UAT environment, and of course now going to production. So what makes release candidates formal is that they are zipped up, they're packaged in .NET. The perfect zip format is the NuGet package, because it's a zip file in structure, but it also contains a manifest, and there's lots of tooling that works with NuGet packages. So you've got your NuGet packages for everything that's going to be deployed, and then all of those are named and all of those are numbered. So just to show you an example of what I mean by formal and what it kind of looks like, this is Azure Artifacts, part of the Azure DevOps suite. And this is a sample application that I've used from time to time on multiple videos. And you can see in Azure Artifacts, the NuGet feed has 3 different packages, and they're all a part of the same application, because we can see the name of the application comes first, Church Bulletin. And then we have the deployed component comes second. The UI is the website, the database, the SQL Server database. We can deploy it with the files in there. And then acceptance test is our full system test that we run against the TDD environment. We have to package those up, and we have to deploy those in a way that they can run against the TDD environment. And we want to run the right version of those tests with the right version of the deployed application. So you can see we have distinct deployable packages, we have a name, and we have a version. You can see right here, version 1.1.46. And if you were to download this NuGet package, you would actually download it, unzip it. You would actually see all the ASP.NET website files. Okay, that's just whatever you've packaged up in your application by calling .NET.exe publish. Okay, so that is formal release candidates. The next is low maintenance environments. Now that's a bit subjective. What makes it low maintenance? But the opposite of a low maintenance environment from an infrastructure side would be a physical server that you have screwed into a cabinet yourself, and it's attached to direct storage, and you're changing out hard drives and spiking hard drives, and you're personally installing Windows updates and patches and all kinds of things. Now that's the obvious side of infrastructure maintenance. So going more towards the serverless spectrum in a cloud environment reduces infrastructure maintenance. But then there's also other things like if you look at a normal 6-month time frame and just ask yourself, in the 6-month time frame, what are the normal tasks that we are going to need to do in order to keep this environment running on all cylinders? Whatever those tasks are is the maintenance of your environment. And so the thought process is thinking, okay, what do I have to do to this environment over the course of 6 months, over the course of a year? And can I change anything about the environment to reduce those number of tasks, to reduce that amount of maintenance? So that's an intentional analysis on your part of creating a low maintenance environment. And you can also extend that to be a low maintenance architecture. If there's aspects of your software where, oh, you know what, we have some type of situation where just about once a month, this backend process, this backend Windows service, maybe if it's an old one, or this service worker, or this queue listener, once a month it kind of gets hung up or does something wonky, and we just want to reboot this thing or restart it once a month because it kind of goes wonky. Well, you know what? That's maintenance. You know that if you didn't restart it once a month, then you could possibly have a disruption. So that is a bit of maintenance. And so over time, thinking, okay, what is causing that? And can I fix it? Can I make it to where it's just automatic? And of course, the first thing you might think is, all right, well, let me create an automated run book that runs once a month and just automatically restarts it. Well, that can buy you some time, okay? But either way, you want to look for the maintenance that you're doing and decrease it. All right. Next is runtime automated health checks. All right. Let me show you an example of one. So over here, let me just get rid of this here. I have a Azure Container App Blazor template. Okay. And this is built in. And then we have this is our kind of skeleton church bulletin application with events at a church, but we have a screen that's actually going to a SQL Server database. Okay. And so what we've done is we've used the health checks NuGet package here, and we've created a URL underscore health check. And when I call it, it actually runs in this application. It runs as many health checks as are in the code base. And a health check is just a class that implements an interface and does a few lines of code. In this particular one, and I've showed it in a past video, we run one to make sure that it's running in a 64-bit process, because if you start on the Azure free plans, the free plans for Azure App Service start with 32-bit. They don't support 64-bit. And so when you want to go to production, if you update or if you just scale up from a free app service, well, it doesn't automatically change the settings that were applied because you were on the free tier. And so 64-bit environments, you can use all the memory. That's one of those things. Another one is that we can actually connect with the SQL Server database, and that there's no firewall issues with Azure SQL and Azure Services. You always have to configure the firewall between them, because Azure Services don't automatically just talk to every other Azure service. It's kind of private by default, and you have to configure it that way. But anyway, this runs all those health checks, which is your custom C# code. And as long as all of them pass, it returns back the term healthy. And if they don't pass, it returns back the term unhealthy. And so you can connect your monitoring tools with this URL, and you can ping this URL at whatever frequency you like. And you want to assert that it comes back with the word healthy, and it's a HTTP status of 200. And if not, then you know something went wacky. And of course, you can configure that for your anomaly alarms or your emergency, depending on which component the health check is for, and if it goes down, if it means that it's an emergency. Whereas some of the components in your architecture, if they go down for a little bit, it's not necessarily an emergency immediately, but if it stays down for some period of time, well, then it does become an emergency. So runtime automated health checks. You absolutely want those in your software. You want the software itself to be able to tell you, I am healthy, I'm ready to go, I'm operating with every component online, everything is working perfectly, and I'm good. You want the software to tell you that. You don't want some tool on the outside inferring, well, I pinged it and the website is up, therefore everything's great. Okay, the website being up is just one factor. Is the website happy? So we're asking the software, whatever it is, are you happy? And so with all different types of software, the health check is going to be different. For the service workers that just sit behind the scenes and process messages coming in on queues, well, guess what? You need to throw a tracer bullet message down that queue, and then make sure the right things come out the other end in order for that to to know if it's healthy. Or you could configure a web service endpoint on a service worker if you choose to, and that's another way of asking, are you healthy? But there's so many different ways of creating runtime automated health checks, and you just have to adapt it to your architecture and ask, do I have a way of knowing right now if every deployed component of this software system is up and running properly and is happy and healthy? If the answer is no, figure out how to work one in. Okay. All right. The next one is production-like pre-production environments. With Azure, it makes it a little bit easier than it used to be, but there's some things that that still might slip by. For instance, it's tempting to use the free tier, like I mentioned with app service, but the free tier, kind of across the board, there's limitations. And so it makes sense. It's going to give you a return on investment in the time of the team to go ahead and get off the free tier. Make sure that none of your environments, even at low scale, none of the environments are using the free tier, because it comes with those restrictions. You want to make sure that you're using the same tier of services as you are in production. Okay, you don't want to let anything be different. You can let the scale of it and the size and the number of CPUs and the amount of memory be different, but that's temporary. If you're going to do a capacity test on your TDD environment, well, guess what? You want to if it's on the cloud environment, you want to automatically scale up that TDD environment to a production-like level before you do those capacity tests, so that you can know. Also, you don't want to be running your pre-production environments with tiny databases, because in production, likely your database is not tiny. Or if you're using whatever your storage is, if you have a folder of PDFs that you write to in Azure Files and you emit these PDF reports, you don't want to be testing in pre-production against an empty folder or one that has 2 or 3, when in production that folder contains 5,000 PDF files. Okay, those kinds of things. So you want to make sure your data is similar. And it's not just the size of the database in SQL Server. Sometimes it's the size of the table. So DBAs for a long time, their tool belt has these scripts that just runs and quickly analyzes the database and tells you, okay, here's all the tables in the database, here's the number of records, and among all of these records, it looks like these columns are most used, and it looks like these other columns are very rarely used, because the same 2 values exist in every single one of them, or these 5 columns 95% of the time are null. But DBAs over time have these analysis scripts that for some reason they haven't made it into a commercial product, but quickly analyze a production database so that you can make sure that you can analyze your pre-production databases and not accidentally have these big differences in the makeup of your storage. Which compute is one thing, the website, the service workers, those kinds of things, but the structure of your storage can make a big difference. Okay. All right. Next one is explicit secrets management. Now that's the fancy way. That's the child's play version of this is, don't put important stuff in config files. And now with with containers being more popular and container images being immutable, there's another reason for not putting environmental specific configuration in a config file, because then it goes into an immutable container, and then it means that that container is locked in with a particular environment. You can't promote the same container from environment to environment. And so that's another force for us to externalize environment-specific configuration. But that doesn't mean that we want to put secrets just in environment variables or in any other text file. We want to make sure that it is in a secrets management service. The new Azure Container Apps does have encrypted secrets management as a first-class citizen. Azure Key Vault, Octopus Deploy has secrets management. Azure DevOps has secrets management. Make sure that you use one of those products. Make sure that you as a team know what configuration keys are a secret and what's just regular config, like the logging level of something, which is not a secret. And in addition to putting it there, make sure that the generation of those keys and the visibility of those keys is not known by the entire team. Okay. And there's so many security vulnerabilities are human based, whereas somebody's credentials are exploited, and then they had access to something, and then everything that they had access to, well, now that's a breach. Okay. So explicit secrets management. All right, the next one, now we go from the engineering practices to prevent production issues to the engineering practices to correct the production issues quickly, recover. Okay, something happened. Now we need some tools to be able to recover really, really quickly. Centralized logging is kind of the first one. We want information, telemetry from all of our deployed components to come to a central place. And Azure Application Insights is one of those that can take centralized logging, but it goes beyond just the logging. And I want to talk about the next one, which is custom application metrics and events. And I'll show you an example of that. I'm going to show you the dashboard of a piece of software that's actually in the Microsoft.NET Showcase, which is the ShowWorks auction product for county fairs, youth livestock auctions. And this is one of the dashboards. And this is kind of regional and segmented, so it's not just one thing that works for the entire world. This is a tenant environment, and different fairs are going on at different times and connected to the environment. So I just went to the time frame for one of the events, and you can see we have a sum of events. Okay, this means that everything that the software did is cataloged as an event, and then we can know the relative busyness of the software. In this type of software, I really don't care about the number of requests per second. I care about the number of things that happened per second, because we could have a bajillion requests for show me a particular lot in the auction and show me a picture and show me the current bid. Okay, that's interesting. But how many buyers did something in the auction? How many bids were placed? How many things changed? How many actual transactions happened? That is actually more interesting than read-only requests. Okay, so that's what this graph represents. This graph represents there was a transaction in the software. The software actually emitted an event. And those are really interesting. Now, server response time over here and receiving response time, those are great. And for a Blazor application, the average open circuits that are there, that's interesting too. The memory usage and then the CPU usage, and then is using Azure SQL. So the amount of DTUs that's used versus the barrier. Okay, some of those things are interesting, but the number of transactions that the application is telling us happened, that's way more interesting than any purely infrastructure metric. So how do we do that? Well, we actually do that in the code. All right, so this particular class is implements the interface iTelemetry sync, and it has a method called record call. And this particular application uses a synchronous in-memory bus, and that bus kind of dispatches to handlers. It uses the mediator library, but wrapping that, every screen wraps up the user's request, wraps up the transaction in a command object, and sends it into a bus, which is down the method. And then the bus delegates to this call, passes that command. So a command implements the iRequest interface, and we're going to record the call. And so two things we want to do is we want to record a custom event, and we want to record the trace. Okay. So if we go down to record custom event and record trace, they're down here, record custom event. This is the Application Insights SDK, and we are actually creating a new event telemetry. We're giving it the name straight off the object. We are adding properties of the full name of the class, because since it's a command, then the name of the class is actually the name of the command. And then we have some reflection code in this method that goes through every property of the command object and adds it as a property of the event telemetry object. And then we finally say, okay, go ahead and track it. We also send the same commands, the same object, to record trace, which all this does is give us a log message, a text log message, where it's literally just the name of it, and then this implicitly calls the toString method on the command. And some of these commands and queries override the toString method just to give more information so that you can kind of read the logs. But that is an example of centralized logging and custom application metrics and events. And that way, your application is actually telling you information. You don't just know, oh, well, my application is running. All right, let me look at the stock infrastructure dashboard. Well, the server is up, and this is how much CPU is used, and this is how much memory is being used, and okay. And well, I guess I can go read the logs, but that's just a big old journal. No. You want to up your game. You want your application itself to be spitting out custom metrics, custom events. All right, now metrics. Let me show you an example of a metric. I showed you the dashboard of it, but in code, any Blazor application, the first custom metric that you're going to put in place for Blazor server side is the number of circuits that are open, because that is the number of users that have a session that's consuming memory on your server. And so you're going to override circuit handler, which this is a Blazor class here. And all you're going to do with circuit handlers, you're going to count up how many open circuits you have and do a little bit of logic. And then we're going to actually send this over to Application Insights. And so with telemetry record metric, our telemetry sync knows how to interface with Application Insights. So we're separating our concerns. This code right here has no idea that we're using Application Insights. Only the telemetry sync does. So we have a class that's an adapter to Application Insights. But we have the metric name and then the value, and another metric name and the value, another metric name and the value. Okay, so that's all a metric is. It's a name and a value, and you want your application to emit it very frequently, and then you can create a dashboard pane, that a line graph that shows the variance in that metric over time. Okay, so that's an important concept with knowing what's going on, because something weird happens in production. You want to look at your dashboard. You want to know what happened with those metrics. Did they stay within thresholds? All that. All right, so that's custom application metrics and events. Next one is distributed tracing. The open telemetry movement is helping with distributed tracing because it's giving what has been proprietary for a long time some concepts and some libraries to build on. So in Service Bus is implementing open telemetry, and you kind of get a lot of this for free. If you're not even familiar with what distributed tracing is, it is a necessity when you have a distributed application. When you have an application with multiple different pieces deployed and all doing different things. They're running in separate processes. They're all doing different things. But if a user takes some action, the fulfillment of that request goes to multiple different processes around your application. And so you need correlation between the logs, the events, and the metrics that happen in multiple different deployed processes, you need all that correlated with a user's request. So that's distributed tracing. And that's pulling that's not saying, show me what's happening with this application. It's saying, show me what's happening with what this user is doing across all of my deployed applications. And that's regardless if you have multiple deployed components in one large application inside one Visual Studio solution, inside one Git repository, or whether you have split up into more autonomous independent services and you have lots of Git repositories, each one having a single service that has its own DevOps pipeline deployed in its own way. If that is coordinated together to be the larger system, you still need distributed tracing. And so definitely people pushing for microservices, if you don't have distributed tracing, something happens in production, you have no idea how to track it down. You're reading logs like you're reading Jules Verne, and you're just trying to figure things out. Okay. Next practice that we suggest is an application performance management tool, APM, with an operations dashboard. Now, if you're in Azure, first thing you're going to look at is application insights. Fantastic tool, great tool. Okay. Datadog is also good. Splunk is good. There's so many good ones out there today. I mean, I could list a whole bunch of them, but if you're in Azure, application insights is probably going to be your go-to until you look at something else and say, ooh, I really like this feature of this one that application insights doesn't have. But if you don't have anything right now, like that dashboard that I just showed you, that's pulling everything together. If you don't have anything right now and you're in Azure, stand up application insights quick. Okay. So, you need to have that tool up and running. Otherwise, you don't have anywhere to go to quickly see the nature of the issue so that you can start fixing it. All right, next one kind of piggybacks on top of all this infrastructure that you put in place is anomaly alerts. And there's a difference between an alert and an alarm. Something weird happens. We don't know if that weird thing that just happened means that some user is disrupted in their job. When we have something weird happens, we also have production issues, and then we have business disruptions. Okay. If there's a business disruption, then there are people telling the software team, hey, I'm down, or this isn't working right. There's actual people in the other part of your business, or there's customers that are yelling because they can't get stuff done. All right. We want to stay multiple stages away from business disruption. So we have weird things that might happen over here, and we have production issues. Then, of course, not all production issues turn into business disruptions. That's why we want to be able to correct production issues quickly, because if we don't correct production issues quickly, then it has time to turn into a business disruption. Okay, there's a lot of production issues that happen, but if we can fix them quickly, the users don't actually know that they happened, and that's the space that we want to live in. So anomaly alerts are alerts that send out an alert to whoever is on call. Hey, something weird has happened. You might want to check. We can't automate something to say this exactly is happening, but you might want to check because this is out of threshold, or this isn't where we want it to be. Okay. And we want those alerts to be coming. It's not an emergency. It's not an all hands on deck. Whoever is on call, and I do recommend you have somebody who is on call to keep an eye out on the production environment, even with small teams. All right, so you want to have anomaly alerts, and that could be, an email inbox or texting to a particular person who's on call. That's fine. Now, you don't want all kinds of trash being alerted. You don't want to use alerts as logs. You don't want to alert as in, oh, this system was restarted, or this system automatically recovered. If you put that into your system, it's like, okay, there's nothing for me to look at. You only want to send an alert when there's actually something that a person should look at. Okay. Next one is alarms. Alarms is automation that you've put in where your automation knows that something is down something is awry and you're already in emergency state. And in that case, we want a all hands on deck type situation. I'll leave it to you to determine what all hands on deck means, because quite literally it doesn't mean all hands on deck. You probably want some people to stay below deck, but it's an emergency. We want to alarm in a big way. And so while an alert might go to just an on-call person, an alarm needs to go a little bit up the chain. It goes to the on-call person and more, but it's also going to go up to management, because if you were running a particular team, you want to know that that team is dealing with an emergency. Okay. All right. So emergency alarms. And again, there's plenty of products out there that do all this stuff. It's not new, but just from a practice perspective, ask yourself, do we have an alert feed on for anomalies, for weird things that happen? Do we sound the alarm when we have an emergency? Have we classified what would constitute an emergency? All right, ask those questions of the team. Those are good team discussions. The last one is a formal support desk. This is a help desk system. All right, you want tickets and you want to track tickets. If you don't have a ticketing system, you need to stand one up. Okay. There's plenty of good ones. ServiceNow, does a lot of integration with Microsoft on the enterprise side. On the medium and small business side, Zoho Desk is super popular and feature rich, and there's other good ones out there. Okay, but you need a ticket system dedicated for this piece of software for your team. And when you set these alarms and alerts, you also want to feed those into the ticket systems and have them auto assigned and whatnot. But you need a formal support desk so that you can record the alerts and what happened. You can record the alarms and the escalation and the communication, and you can record outages, resolutions to outages, and you also want your customers reporting their issues back to the same place. And so you have a centralized way to manage production issues. And a lot of these ticket systems also come either built in or with a sister product, knowledge bases, where every time that there's a production issue, and you get it fixed and you're back up and running, you create a knowledge base article for what happened, and now it's searchable for all future teammates to kind of refer back to. Okay, so just to recap, first step in implementing the clear measure way is to establish quality. The second step is to achieve stability, which we've been talking about the engineering practices to achieve stability, because the next step is increase speed of your team. With quality and stability, now your team can actually work on going faster. If the team tries to work on going faster and you haven't established quality and you haven't achieved stability, then there's things that are breaking, and then a portion of the team's capacity is distracted fixing these things, and you're constantly trying to take a step forward and taking 2 steps back. So it's really important, this step, achieving stability. Use these engineering practices to achieve stability in production. And by the way, this is not an exhaustive list for your particular architecture, for your particular situation. There may be another one or several practices that are useful in your situation. But in our experience, these engineering practices should be used by every software team. I hope these engineering practices aid you and your team in achieving stability. There's a lot that goes into them, but the great part is that very few of them are new. Actually, they've been around for a long time. The tooling and the guidance on them has gotten better over the years, and there's plenty of materials out there, plenty of books, great commercial products, and so I just want to encourage you. You can do it. You're leading your team to establish quality and achieve stability and to go faster, to increase their speed. And so these are just kind of the basic engineering practices that need to be put in place for achieving stability. And of course, you'll come up with one or two, but you can do it. and you are responsible for leading your team. It's a big job, but you can do it. Like I like to say, now go do it. Thanks for being with me on Programming with Palermo, and God bless.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at Palermo.network as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.